Hello, my dear students. Welcome to the subject of social science for the class 10th English medium. Today we will be discussing chapter 12, that is India, Minerals and Energy Resources, presented to you by Vitan sir. Now, before we talk about minerals, how have humans evolved? It has been divided into four stages. The first stage was the Stone Age, where humans used stone equipments to advance in their civilization. Then came the Bronze Age. After that came the Age of Iron, where they developed the iron tools. And the latest, the today's age, is known as the modern or the atomic age. It can also be described as the age of minerals. What is a mineral? The matter which is formed due to the inorganic process and has a certain chemical composition is called a mineral. Let me repeat again. The matter which is formed due to inorganic processes means something which is not organic, something which is not living and has a certain chemical composition, means we can define its composition through a chemical formula, then we call it a mineral. Minerals are the backbone of nation's economy. For any nation, minerals are vital. The example here is that the US and Russia achieved development through extensive use of minerals. Now, these are some of the examples of minerals. These are the raw minerals. They have not been processed. These are as received from the nature. The solid, liquid or gaseous, that means minerals are divided into three parts. They could be solid, liquid or gaseous. They have specific abiotic processes within the rocks in the interior of the earth. They have a certain chemical compositions and they are homogeneous in nature. That means if I talk about iron, all the ions are iron themselves. They have a similar compound. If I talk about copper, then it's just copper. The examples said some of the minerals solid are iron, manganese, gold, silver. The liquid minerals are the mercury and petroleum, and the gas includes any gaseous elements. The type of minerals that are available for the interior of the earth depends on how the crust of the earth originated. For example, iron, copper, zinc and gold, silver are from the igneous rocks. In the ninth standard of SS, we have studied that igneous rocks basically means rocks created out of lava. So these are the minerals iron, copper, zinc, gold, which are received from the rocks created out of volcano and lava. Diamonds are found in the metamorphic rocks. We have learned about three types of rocks in the ninth: igneous, metamorphic and stratified. The petroleum products, coal, are usually found from stratified rocks. We will start with the first topic of this chapter, that is the classification of minerals. The minerals are mainly classified into three types: metallic minerals, non-metallic minerals and the energy sources, means the minerals used to gain energy. We will see these classification into detail, starting with the metallic minerals. The first type of metallic minerals are the precious metals. You can take example like gold, silver, platinum. Second are the light metals, for example magnesium, bauxite, titanium. Next are the common metals, for example iron, copper and lead. Last are the alloys. Alloys are the metals created with the mixture of more than two or more metals, that is chromium, tungsten, etc. Non-metallic minerals, minerals which are not metals, are limestone. We can also call it chalk. Yeah, that's chalk. Asbestos, mica, gypsum, diamond. There are maybe many more examples of non-metallic minerals. Energy resources, the minerals which provide us with energy, are coal, mineral oil, natural gas, uranium, thorium. Now, some of these minerals we will discuss in detail. We will start with iron ore. This is the picture of how a raw iron looks like. After that, it is processed. Iron is considered to be the base of industrial development. That means whatever industries we see today works based on iron. It is used for making small pins to large machines, cars, trucks, ships, and plethora of things. It is very cheap, it is strong, and it is durable. It is available geographically in almost all the countries, and the main importance of iron is that it can be mixed with other minerals, and therefore it is very important for industrial development. Iron is found in impure conditions and it is mixed with coke and lime in the large furnaces for the refining. This you have studied in the science subject. The pure iron which is obtained is known as pig iron. There are four types of iron found in India, that is hematite, magnetite, limonite, and siderite. The maximum iron ore in India is obtained from Karnataka. Apart from that, Orissa, Jharkhand, Chhattisgarh, Andhra Pradesh are other states who produce iron. In Goa and Rajasthan also we can find the iron. Manganese. This is how the manganese ore looks like. It is very important mineral for iron and steel industry. Reason being, it is used to make steel from iron. That means manganese is used to convert iron into steel. Apart from that, it is used for bleaching powder, insecticides, dry battery cells, and tiles. Also, it's used in industries like leather, glass, matchbox, photography, china clay, and colored bricks. Rails made out of steel rods become more flexible and strong. Steel is used in the machines to break rocks and also in grinding machines. Odisha, Karnataka, Madhya Pradesh, and Goa can be counted as major states of manganese producers. Apart from that, it is also obtained from Andhra Pradesh, Jharkhand, Rajasthan, and Gujarat states. Next is copper. This is the copper ore in its raw form. Copper is used since primitive times. As we know, the second age was the copper age. The first mineral used by man is also copper. It is more important because it can be mixed to make new minerals. It can make bell metal when mixed with tin and makes brass when mixed with zinc. It is also used in making electrical equipment, telephone, radio, television, refrigerator, and air conditioner because it is a good conductor of electricity. It is also a killer of bacteria, hence used for insecticides, explosive, colored glass, coins, and in printing paper. Copper is maximum produced in Jharkhand, Madhya Pradesh, Rajasthan, etc. states of India. Apart from that, Sikkim and Andhra Pradesh is also producing copper. Bihar, Karnataka, Maharashtra, Tamil Nadu, Himachal Pradesh, and Uttarakhand states have the copper content in their soil. Bauxite, and this is how the bauxite ore looks like. This is the aluminium ore. That means the bauxite is used to create aluminium. It was found in 1921 in France at a place called La Box. It means the box, and hence the name bauxite. Aluminium is obtained from bauxite and it is useful due to its special property. Its weight is almost the lightest in all of its category of minerals. It is very strong, durable. It can also conduct electricity. It is rust free and easily ductile. That means it can be molded into any shape easily. It doesn't get rust. It is light in weight. It is strong, durable. It conducts electricity. What more do you want from a metal? It is widely used in the making of domestic utensils, electrical gadgets, colors, and in shipbuilding. It is obtained in India from Odisha, Chhattisgarh, Maharashtra, Jharkhand, and Gujarat. Usually in the Deccan Tract of India, this kind of mineral is obtained. In Ranchi, Jharkhand, and Jamnagar, Bhavnagar, Junagadh, Amreli, Surat, and Sabarkantha districts of Gujarat produce bauxite in plenty. Mica, and this is the mica ore. India ranks first in the production of mica. It is a bad conductor of electricity, so it is used in electrical motors, dynamo, radio, etc. Bihar, Jharkhand, Andhra Pradesh are major producers of mica. Muscovite type of mica is found in India in a big quantity. Lead. Lead, which is also known as galena, is soft and heavy in weight. It is used to make alloys, wires, color, weapons, glass, rubber, etc. things. It is available in Rajasthan, Andhra Pradesh, and Tamil Nadu states of India. Limestone, and this is the picture of how the limestone looks like. It is found in many places in the world and it is used for the production of cement. It is also used for melting iron for the chemical industries, as a soda ash, soap, color chemicals, building construction, paper, and in sugar refining. Andhra Pradesh, Rajasthan, Madhya Pradesh, Gujarat, and Tamil Nadu produce 70% of limestone of the country. Besides this, other states also produce limestone in small quantities. In Gujarat, Jamnagar, Kutch, Amreli, and Kheda are the major limestone producing districts. The rocks in Jamnagar district contain about 97% of the lime content, meaning they are very rich as the lime. Minerals of energy resources. These include coal, mineral oil, natural gas, and the atomic minerals. The classification of energy resources. They could be classified into two parts. The first part are known as commercial or conventional or non-renewable energy resources. These are the resources which are usually used, sold in the commercial markets, and they are non-renewable, means once you use them, they never recreate themselves. The example of them are coal, mineral oil, natural gas, and atomic minerals. The second part are non-commercial, non-conventional, and or renewable resources. They are not usually made available in the commercial markets. They are not usually used, but they can be recreated as many times as you want. The hydro energy, that is the water energy, the wind energy, solar energy, tidal energy, all of these are non-commercial, non-conventional resources, while pit coal, firewood, and dung, that is the cow dung, are the renewable energy resources. Let us discuss them in detail one by one.
Coal. Coal is a black or dark brown combustible rock made primarily of carbon. It was formed millions of years ago when ferns, plants, and trees died and fell into swamps. The swamp conditions prevented the organisms from decaying completely, and after millions of years of intense heat and pressure, coal was formed. Coal is classified into four main types or ranks based on carbon and heat content: lignite, subbituminous, bituminous, anthracite. The general rule is that the higher the grade of coal, the cleaner it burns and the more versatile its uses. Coal is extracted from the earth through underground mining or surface mining. The choice of mining method is largely determined by the geology of the coal deposit and its distance from the surface. Underground mining currently accounts for a larger share of world coal production than surface mining. Coal can be burned for heating or to produce electricity. To convert thermal coal to electricity, it is first milled to a fine powder, which increases the surface area and allows it to burn more quickly. The hot gases and heat energy produced from combustion converts water into steam to run a turbine and generator. High-quality coal is also a useful raw material. For example, it can be converted to coke for steel making. Coal can also be converted to liquid or synthetic gas by advanced chemical processes, making it a possible but costly replacement for natural gas or liquid fuels for transportation. Coal is a highly abundant and cheap energy resource. Coal has powered the industrialization of many nations over history and continues to today. It is a big player in today's energy system, providing 40% of the world's electricity. One major concern with coal is the mining practices used to extract the resource. Ecological impacts and human safety issues, both for workers and neighboring communities, are growing concerns for the industry. Coal is the most CO2-intensive fossil fuel when combusted because it is composed largely of carbon. Coal also contains other elements that cause pollution problems, including sulfur, nitrogen, mercury, and heavy metals. SOx is a leading cause of acid rain, and NOx emissions contribute to smog. In addition, particulates from coal combustion can be harmful to human health. Concerns about climate change from greenhouse gas emissions have put a spotlight on coal plants and have prompted the development of clean coal technologies like carbon capture and storage. That's coal.
We will start with coal. It was created during Carboniferous period, which was before 25 crore years from today. Jharkhand, Odisha, West Bengal, Chhattisgarh, MP and Jammu and Kashmir produce maximum coal in India. In Gujarat, Kutch, Bharuch, Mehsana, Bhavnagar, etc. has coal fields.
Oil. Oil, otherwise known as petroleum or crude, is a thick black liquid composed primarily of hydrogen and carbon. The physical properties of oil, such as its thickness, vary greatly depending on the specific combination of hydrocarbon molecules. Oil also contains trace elements of sulfur, nitrogen, and oxygen. Today's oil deposits were formed millions of years ago when dead marine organisms sunk to the bottom of the ocean bed and were buried under deposits of sedimentary rock. After subjection to intense heat and pressure, these organisms underwent a transformation process by which they were converted to oil over millions of years. This is why you may have heard oil referred to as a fossil fuel. Oil is found in underground geological formations called reservoirs. The rocks found in a reservoir have various physical properties that allow them to hold hydrocarbon reserves. Through exploration activities such as seismic, surveying, rock core sampling, and other advanced technologies, geologists locate oil reserves. Oil is extracted from the reservoir most commonly by drilling a well. Once recovered, oil is transported by pipeline, ship, rail, or truck to a refinery where it undergoes a complex refining process that creates petroleum products like gasoline, diesel, jet fuel, asphalt, and many more. Currently, the world uses oil primarily to power its transportation system and to create commonly used synthetic products like plastics and petrochemicals. The production and use of oil presents social and environmental challenges. Producing oil causes land disturbance, sometimes in environmentally sensitive areas. Oil-powered transportation systems contribute to global greenhouse gas emission levels. And control of oil resources is a persistent factor in geopolitical tensions globally. That's oil.
Mineral oil. In 1866, the first oil well was dug in Makum, that is Assam, and oil was discovered in the year 1867. Indian oil fields are divided into 5 parts, that is Northeast, Gujarat, Bombay High, Eastern Coast and Rajasthan. In Gujarat, the first field was struck in the Lunaj, that is Kheda district, in 1958. Then it was found in Ankleshwar, Mehsana, Kalol, Navagam, Kosamba, Anand, etc. places. The mineral oil refineries of India are located at Guwahati, Barauni, Koyali, Kochi, Chennai, Mathura, Kolkata, and Haldi places and districts. In Jamnagar, Gujarat, the largest oil refinery is located.
Natural gas. Natural gas is primarily methane, or CH4, with smaller quantities of other hydrocarbons. It was formed millions of years ago when dead organisms sunk to the bottom of the ocean and were buried under deposits of sedimentary rock. Subject to intense heat and pressure, these organisms underwent a transformation in which they were converted to gas over millions of years. Natural gas is found in underground rocks called reservoirs. The rocks have tiny spaces called pores that allow them to hold water, natural gas, and sometimes oil. The natural gas is trapped underground by impermeable rock called a cap rock and stays there until it is extracted. Natural gas can be categorized as dry or wet. Dry gas is essentially gas that contains mostly methane. Wet gas, on the other hand, contains compounds such as ethane and butane, in addition to methane. These natural gas liquids, or NGLs for short, can be separated and sold individually for various uses, such as in refrigerants and to produce products, like plastics. Conventional natural gas can be extracted through drilling wells. Unconventional forms of natural gas, like shale gas, tight gas, sour gas, and coal bed methane, have specific extraction techniques. Natural gas can also be found in reservoirs with oil and is sometimes extracted alongside oil. This type of natural gas is called associated gas. In the past, associated gas was commonly flared or burned as a waste product, but in most places today it is captured and used. Once extracted, natural gas is sent through small pipelines called gathering lines to processing plants, which separate the various hydrocarbons and fluids from the pure natural gas to produce what is known as pipeline quality dry natural gas before it can be transported. Processing involves 4 main steps to remove the various impurities: oil and condensate removal, water removal, separation of natural gas liquids, sulfur and carbon dioxide removal. Gas is then transported through pipelines called feeders to distribution centers or is stored in underground reservoirs for later use. In some cases, gas is liquefied for shipping in large tankers across oceans. This type of gas is called liquefied natural gas, or LNG. Natural gas is mostly used for domestic or industrial heating and to generate electricity. It can also be compressed and used to fuel vehicles and as a feedstock for fertilizers, hydrogen fuel cells, and other chemical processes. Natural gas development, especially in the United States, has increased as a result of technological advances in horizontal drilling and hydraulic fracturing. When natural gas is burned, there are fewer greenhouse gas emissions and air pollutants when compared to other fossil fuels. In fact, when used to produce electricity, natural gas emits approximately half the carbon emissions of coal. Despite fewer emissions, natural gas is still a source of CO2. In addition, methane is a potent greenhouse gas itself, having nearly 24 times the impact of CO2. During the extraction and transportation process, natural gas can escape into the atmosphere and contribute to climate change. Natural gas leaks are also dangerous to nearby communities because it is a colorless, odorless, highly toxic, and highly explosive gas. That's natural gas.
Natural gas. The reserve of natural gas in India is found in Khambat Basin, Kaveri Basin, and Jaisalmer. Ankleshwar of Gujarat is said to have largest natural gas reserves. Non-conventional energy sources. US, Russia, France, Canada, Australia, Japan, etc. have taken steps in this field. In 1981, the Commission for Additional Sources of Energy, that is CASE, was established in India. Also in Gujarat, Gujarat Energy Development Agency, that is GEDA, was established for the same purpose.
Solar. Solar energy is the most abundant renewable energy source in the world. Solar energy systems employ technologies that convert the sun's heat or light to another form of energy for use. There are two categories of technologies that harness solar energy: solar photovoltaics and solar thermal. Solar photovoltaic, or PV, is a technology that converts sunlight into direct current electricity by using semiconductors. In contrast, solar thermal is a technology that utilizes the heat energy from the sun for heating or electricity production. Solar is a renewable resource and does not emit any greenhouse gases. However, efficiency and intermittency are issues. Since sunlight is dependent on location, season, and time of day, harnessing the energy from the sun is a challenge. That's solar.
Solar energy. Gujarat has maximum solar energy in India. GEDA has established solar cold storages near Vadodara of 10 tons capacity. A solar energy plant has been installed at Madhopura near Bhuj for desalination of salt water. Here, the desalination means that the salt water of the sea is made drinkable by removing the salt, and the energy required to make the desalination is created from the solar energy plant.
Wind power. Wind, although it might not need explaining, is moving air caused by differences in atmospheric pressure. Wind speeds vary based on geography, topography, and season. Because of this, like other renewables, there are some locations better suited for wind energy generation than others. In fact, there are optimal wind locations both onshore and offshore. Energy is derived from wind by converting the air's motion into mechanical energy. Traditionally, this energy was used for milling grain and pumping water, but today is most commonly used to create electricity. The mechanism used to convert air motion into electricity is referred to as a turbine. A turbine is a large structure with several spinning blades, usually 3. These blades are connected to an electromagnetic generator that generates electricity when the wind causes the blades to spin. Wind is becoming an increasingly important part of the global electricity supply mix. A major advantage of wind is that the production of electricity has no direct CO2 emissions. But wind generation is not without its challenges. As everyone knows, the wind does not blow all the time, causing intermittency issues for power grids. The price tag of wind power has traditionally been higher than conventional electricity generation sources, though the wind cost curve has declined significantly in recent years. NIMBY concerns such as land use, noise, and bird disruption have also been raised in certain areas. That's wind power.
Wind energy. India has become fifth country in the world to produce energy from wind. Gujarat, Tamil Nadu, Maharashtra, Andhra Pradesh, Odisha, Karnataka, Madhya Pradesh, and Kerala produce wind energy in good quantities. In Gujarat, wind farms operate in Mandvi, Jamnagar, Rajkot, Porbandar, etc. places.
Wind power. Wind, although it might not need explaining, is moving air caused by differences in atmospheric pressure. Wind speeds vary based on geography, topography, and season. Because of this, like other renewables, there are some locations better suited for wind energy generation than others. In fact, there are optimal wind locations both onshore and offshore. Energy is derived from wind by converting the air's motion into mechanical energy. Traditionally, this energy was used for milling grain and pumping water, but today is most commonly used to create electricity. The mechanism used to convert air motion into electricity is referred to as a turbine. A turbine is a large structure with several spinning blades, usually 3. These blades are connected to an electromagnetic generator that generates electricity when the wind causes the blades to spin. Wind is becoming an increasingly important part of the global electricity supply mix. A major advantage of wind is that the production of electricity has no direct CO2 emissions. But wind generation is not without its challenges. As everyone knows, the wind does not blow all the time, causing intermittency issues for power grids. The price tag of wind power has traditionally been higher than conventional electricity generation sources, though the wind cost curve has declined significantly in recent years. NIMBY concerns such as land use, noise, and bird disruption have also been raised in certain areas. That's wind power.
What is biogas? Biogas is a clean, sustainable, and economically friendly source of energy. How does biogas produce? Biogas is produced through a natural process called anaerobic digestion that turns organic waste, like animal waste and food waste, into two products. The first product is a clean gas called biogas. It is used mainly in rural area for lighting, heating, and cooking. The second one is a high-quality organic fertilizer, which is used by the farmer for their plants to replace the chemical fertilizer.
Biogas. Uttar Pradesh and Gujarat has first and second places respectively in the biogas production of India. The largest biogas plant is installed at Vitan near Siddhpur in Gujarat. Others are at Rudratala, Dantewada of Gujarat state.
Geothermal. Geothermal refers to producing energy from the internal heat of the earth. The internal heat of the earth is generated from radioactive decay of minerals and continual heat loss from the earth's original formation. Geothermal wells are drilled into the earth's crust at approximately a depth of 3 to 10 kilometers. The heat is extracted with a variety of methods, but in most cases is drawn from the earth using water and steam. Hot water from the earth may be directly extracted to heat homes and buildings. This is done either by directly circulating the hot water through buildings or by pumping it through a heat exchanger that transfers the heat to the building. Geothermal heat can also be used to produce electricity in a geothermal power plant. Electricity is generated when geothermal heat produces steam that turns turbines on a generator. The major regions of geothermal development are in the most volcanically and tectonically active regions of the world. Though geothermal energy is currently a small player in the world's energy mix, one of its key advantages is its reliability and consistent power generation, which means it can provide baseload electricity. Concerns with geothermal include the accidental release of CO2 and hydrogen sulfide emissions stored in the Earth's groundwater that is often used to carry geothermal heat to the Earth's surface. Additionally, drawing heat from the Earth's crust can, if done irresponsibly, lower the ground temperature below the surface. The upfront costs for geothermal energy production are relatively high. It is expensive to carry out the seismic sensing, test well drilling, confirmation testing, and other necessary preliminary investigations to ensure that your new geothermal plant will be capable of meeting desired production. That's geothermal.
Geothermal energy. Hot water springs in Gujarat are located in Lasundra, Unai, Tuva and Tulsi Shyam. These locations can be utilized for creation of geothermal energy.
Tidal power. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity and therefore do not provide sufficient capacity to satisfy demand. That's tidal power.
Tidal energy. In 1910, France started this project for the very first time. This project has been started in India at Gujarat on Gulf of Kutch and Gulf of Khambat. Mineral preservation and remedies for mineral preservation. With the increasing usage of the minerals, we need to preserve them. And what could be its remedies? I have prepared a small clip which includes these topics in an entertaining manner for you guys.
A total of 39.3 billion tons of metal ores, fossil energy, and non-metallic minerals are extracted from Earth each year. But because of excessive mining, these resources are depleting. On average, everyone uses 16 kilos of resources extracted from Earth every day. It goes into your products. Telephones are made from 42 different minerals, television requires 35, and computers more than 30. Production of mined metal commodities is expected to increase by 250% by 2030. Mining operators often lack the know-how in applying sufficient health and environmental safeguards. Therefore, environmental impacts of mining is likely to increase. Because of these mining practices, our mineral resources are constantly being depleted. So, how can we conserve mineral resources? Here are some few examples.
What we learnt about in this tutorial. What is a mineral? Types of minerals, metallic minerals, commercial energy minerals, and non-conventional energy minerals. At the end, how to preserve these minerals. My dear students, with this I end my tutorial here. Next time we will be studying about some of the manufacturing industries of India. Till then, stay tuned, stay home and stay safe.